Okay. So we now need to start talking about inheritance. So in object-oriented programming, so this is when a class receives public and protected members from a parent class. And to show you what that means here, there is a built-in hierarchy in Java. So automatically, every single class we ever create inherits from object. All right, so let me show this to you. We're going to go in here. I'm going to create a new project. And we're going to call this guy, let's see, what should we call this guy? Call this guy Fight Club.
We're not talking about Fight Club. So the first rule.
Fight Club 535 Spring 2016. Alright, so and then we'll create our class in here. We'll call it driver. Alright, this should not do anything right now, but that's fine. Okay. So, as an example, we're going to go ahead and we are going to create a, we've dealt with random numbers already, right? Javadoc random. So let's go ahead and use one of those guys. We're going to need them today anyways. New random. And this is going to want me to import java.util.random. And now we've seen already that if I do system.out.println r, that a memory address prints out, right? We've seen that. Okay, memory address prints out from that guy. And let's go and look at why. So I'm going to go to java.sun.com. And we're going to go to the documentation here. So we're going to go to Java SE, Java APIs, and Java SE8. And I'm going to select, we haven't looked at the documentation yet, have we? In here? Okay. So up here in the upper left, this is all the different packages that exist in Java. So for instance, inside of java.util, right here, we will find the random class. Oh, its class is down here. So there's that dude. That's where he lives. Okay? But by default, if we don't do anything special, we have access to this thing called java.lang. This is the core Java programming language, everything that's in here. So this is where string lives. This is where system lives. So system.out.println. If I click on system, here's system. Inside here we have a field called out of type print stream. And print stream has a whole bunch of printlns, prints and printlns that know how to print a whole bunch of different kinds of things. Make sense? All right. And one of the printlns, this guy right here, takes an object as a parameter. And when he takes an object as a parameter, this is a generic object. So when he takes an object as a parameter and he tries to print that object, he has to drop down to the lowest common denominator for that object. If I click on object, we're going to see in here that this guy has a method called toString. Every single object in the Java language has a method called toString that returns a string representation of the object. That's guaranteed because the object class lives at the very, 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 very top. That is to say, if we were to draw a picture here, here's object, random is one of those guys. Therefore, he gets the toString method from object. We go back in here to the documentation. Let me go back to random. Go to java.util. Scroll down to random. Up top here, we see that here's java.util, and he inherits from java.lang.object. His direct ancestor, his direct parent, is java.util.random. Okay? Now I'm going to go ahead and create another class in here. All right, we're going to call this guy's going to be a class, and we're going to call this guy a fighter class. We have fighters in Fight Club, right? So this is a fighter class. Okay, I'm literally going to put nothing inside that class right now. I'm going to leave it alone. It's just a public class fighter, has nothing else in there. I will leave random there for a second. So we're going to say fighter f is equal to new fighter. So now if I try to print out f, it's going to print out a memory address. There's a memory address. Why is that? Well, I didn't write anything inside a fighter. Up here, there's some invisible text. Remember when we talked about the evolution of C++ to Java? We mentioned that some of the weaknesses of C++ is they allowed programmers to make bad decisions and that kind of stuff. And then we also talked about that we went to Java. Java makes a lot of those decisions for you. So many decisions that it hides some stuff from you. All right? So there's some invisible text here that says extends object. It'll still run. It was already there even though we didn't see it. It was assumed to be there. So now, if we go back to this model right here, we have now a brand new class that also extends object. Every single class that we ever create or that has ever been created in Java all have at least one ancestor, and that's object. That is why we can guarantee that every single class that we create or every single class that's ever been created has all of the stuff that's in object, including that toString method. That allows the printstream class to write println in terms of the generic object's toString. Does that make sense? And to prove this to you, I'm just going to come in here and I'm going to say public string toString, and I'm going to return woot. All right. So a fighter now has his own version of toString that shadows the one he got from object. It's a more local definition of toString. I've overridden my parent's one. The one my parent gave me, I decided to re-implement it. There's my woot. There's our evidence that the println method is calling upon whatever object you passed its toString method. That make sense? I just happen to write a more local one. That's why fighters can now print out things that are not memory addresses. Now, if I really want the memory address, I can concatenate onto this guy. I can say super.toString. Super is how we refer to our parent. So now I'm saying, okay, look, Pops. I have my own version of toString. I'm my own man, my own object, and I say woot. Okay, but you know what? I'll let you go ahead and do your job too. So you go ahead and let me know what you have to say, and I'll concatenate it on to what I have to say. So now we'll have woot followed by the memory address. That make sense? All right. So this is how the inheritance model works in, or actually all object-oriented languages, but specifically in Java in this case. So everything comes from objects. So every object knows how to do some things. And the one that we're kind of interested in right now is that whole toString thing, because we like stuff to print out nice, right? You know, so we could go back to our Connect 4, and instead of having a display method, we could have a method called toString that happens to generate the same string that the display method was printing out. And then we could just say system.out.println passing it a board, and it would print it out. Display the board nicely. Because it would no longer be calling the generic objects toString. It would now be calling the boards less generic, assuming to be less generic toString. Okay. So, in any case, we have our fighter. And we have random. Both of these guys inherit from object. Now what we can do, and we're going to keep this fairly simple at first, I'm going to create another new class. All right, so we're going to have a wizard, right? So, because we have magic fighters in Fight Club. I don't know what Fight Club you go to, but my Fight Club, the same place where we play the professional Connect 4. It's also, we also do Towers of Hanoi. LARPers. I don't think they know what LARPers are. Live action role playing. Yeah, we don't have we don't have a group of LARPers here.
We had some up.
Okay. Yeah, University of Illinois. When I went to school there was a pretty good sized group of people you would see on the quad, sword fighting.
I had a neighbor that was a LARPer.
Yeah. They walk around wearing capes and armor. But it's like armor that they made, and some of it's like really legit. A lot of it's not. A lot of it's like garbage cans.
My neighbor used to was a LARPer, and that's what he would do on the weekends. He'd either play battles or he was building his armor out in the backyard. So.
All right, so here's our wizard. We're gonna say that a wizard extends fighter. All right, so we're saying that the class wizard actually extends the class called fighter, which extends the class called object. That make sense?
So you're cascading.
Yep. Okay. So now again, this guy is not required. We don't have to have that extends object there. In fact, it would probably be pretty rare for you to have it there. I just wanted to prove to you that it is there. It's a thing. Okay. So now, if we were look at the picture, now we have a wizard that goes right here. Okay, and if we go back into our code and we go to driver, and now we go ahead and create a wizard. Wizard W is equal to new wizard, and then we print out W. We put nothing inside of wizard. This guy is empty. So he gets his parents' toString. Well, his parents' toString is this. His parent says woot and then calls his parents' toString. Super. And his parent does the memory address thing. So if I run this, we get woot wizard at this guy. Make sense? Weird memory address of this object. All right, even though we didn't write anything inside of wizard. So wizard actually got his unique toString ability from his direct parent, which was fighter, who got his toString ability that he chose to overwrite from his parent, which is called super, which happens to be object in this case. All right. Now, having said that, nothing keeps me from doing this. I can say public string toString return super dot toString. Complete waste of time, because that's already happening, right? This is already happening. So I'm saying, oh, I'm going to go ahead and overwrite the parent's toString, the toString that I inherited, that was given to me by my parent, the great and mighty fighter. Okay, I'm going to choose to override that. I'm going to write my own version of that guy, except I'm just going to ask him to do it. So even though I wrote my own version, I'm still actually just passing the buck to my parent. So I'm pretending. Okay, I'm pretending. So this is still going to have the exact same output. All right, but I could return C and then tack it on there. And now we have C Woot Wizard. So the wizard knows how to, well, it doesn't have to go before. You can say super dot toString concatenated with C, and now the C will come after. So this specifically came from our wizard. This came from object. This came from fighter. That make sense? So that's how inheritance works. We were just working with something that we specifically got from the object class. Now, usually we don't want to see memory addresses, right? Usually we want to see something more specific to the type of object, but so println can work. Objects had to have that toString method written so that println could assume that every single object will definitely have one of those guys, whether he wrote a better one himself or just relied on the one that was provided. Okay? Either one. All right, so let's look at this. So when we think about Fight Club, we'll go ahead and take out toString right now. We're going to say that all fighters have a name, right? So we're going to say private string name, and then we'll have our public constructor for fighter, public fighter string name, and we'll say this dot name is equal to name. All right, and then we'll go ahead and rewrite the toString. So we'll say public string toString, and this guy will return I am this dot name the great fighter. All right, so that's what that guy will do when we fight. Now notice here in Wizard, I'm going to go ahead and actually we'll dump toString for a second. We'll save this. Wizard's not so happy right now. Right? We look at Wizard. Wizard says implicit superconstructor fighter is undefined for default constructor. Must define an explicit constructor. So since we specifically wrote a constructor here for fighter, we now need to write our constructor for wizard in terms of a fighter. The assumption is to be made that a wizard is a fighter, but he might be a little bit more. All right, but we're going to start off by just saying a wizard has a name. So we're going to say public wizard string name, and then we're going to say this dot name is equal to name. And it's going to scream at us. Why is it screaming at us? Well, it's saying, wait a minute, the field fighter.name is not visible. Well, why isn't it visible? We go back here. Made it private. Private means it's only accessible within the class named fighter. Public means it's accessible everywhere. Protected means it's accessible within a class as well as its children. All right. Well, let's take a different approach here before we fix that. So I'm going to go ahead and I'm going to call upon my parents constructor. If I want to use my parents constructor in Java, it has to be the very first line in the code. Because the idea would be when we talk about inheritance, I'm a wizard, I am also a fighter, and I'm also an object, right? The idea would be if I'm a wizard, I have everything in common with the fighter, but then I might have some extra stuff. So it seems to make some sense that I might want to go ahead and, so we don't duplicate a lot of code, I might want to go ahead and have my direct parent fighter partially build me. Let his constructor do some of the work because I've already written that code. And then I'll just do the extra special stuff that makes me unique. That make sense? All right. So that's why this, if we call upon our parents constructor, so we're still using the super keyword, but we're specifically using it with parentheses after it. This is a specific call to my parents constructor. Okay? that line must come first. It must be the very first logic line. You can have comments before it.
So you still have that as private? It's still able to resolve that?
Well, because I passed name to my parent fighter, and this guy has access to name. All right, so now I've built that. So let's go back into driver. So now fighters require a name. Let's see, what's a good name for a fighter? Conan?
There you go.
Well, Conan's a barbarian.
Yeah, he's still a fighter.
Well, he's not a generic fighter. A generic fighter would be like Tim.
Steve.
Steve? Fine, Steve. Steve's a we'll make a barbarian class. So we can have Conan the barbarian. Okay. Let's see. Wizard. This should be. Oh, you want to do Gandalf or Harry Potter?
Oh, Gandalf's a better wizard.
Did I spell Gandalf? Is that it?
Yep.
Close enough. All right, so we have Steve and we have Gandalf. And then we'll go ahead and print out Gandalf. Okay, I am Gandalf, the great fighter. Wait a minute. Okay. Well, he's Gandalf. Why? In Wizard, we did not write our own two-string. And since we did not write our own two-string, what we did is we passed the buck. Okay, so this is an important thing for us to understand how things resolve. Several classes ago, probably 3 or 4 classes ago now, we talked about variable resolution, how important that is, that a variable resolves to its most local definition. When we look at a value, we have to actually think about what will that boil down to. When we look at a variable, rather, what will that boil down to in terms of its final value? Make sense? So with that in mind, when I call system.out.println on a wizard, since we're seeing this work, we see it say, I am Gandalf, which was the name of our wizard that we passed to our parent to print for us, the great fighter. We know that it says the great fighter because that's what fighters say, right? But the question is if I'm a wizard, before I tell you, what does this imply about the two-string method as it relates to wizards? In this case, we did not write our own two-string method. Instead, we inherited the two-string method from our parent. What does this, the output of this, imply to us, or even the fact that this is running? What does that imply to us about how that inherited method actually works? I'll give you options. Does wizard get the two-string method? Or does he just have a channel to his parent, and when println tries to call the wizard's two-string method, the wizard says, I don't know what to do with this, but I'll go ahead and toss it to my parent and see if he knows what to do with it. So does the wizard himself get a two-string method that he can call? Or does he actually just pass the buck to his parent? Okay, how do you know?
Well, because you tell him it's super right there. I mean,
No. I don't have a two-string in here.
But I understand.
No two-string.
Well, it's because you're sending the public class itself to fighter, which fighter inherits from its parent already.
It's automatically maybe hidden in
Java.
It's just automatically doing it.
Here, we'll go back here. I'm going to say w dot two-string. Same output. So is this proof that println for objects print out called the two-string method? If you remember correctly, when we were looking at the system class, Javadoc, there was a whole bunch of different println methods. There was one that took in a string.
Yeah.
We just called that one because we called two-string for him. So here's a println that takes in a string, and then here's a println that takes in a generic object. We pass it a string, that string already has his own toString method that does the right stuff for strings. If we pass it an object, he calls that object's toString method. Okay? So me specifically saying toString here actually forced it to call a different version of println. It's no longer calling the version of println that takes an object. Now it's calling the version of println that takes a string. Okay? So let's define that real quick. Funny name. Polymorphism. This is more than one method in the same class that has the same name but a different number and or type of parameters. So we have a println method that takes an int. We have a println method that takes a char. We have a println method that takes an object, one that takes a string, so on and so forth. So a whole bunch of different methods that are identical in name, but actually take in a different number and or type of parameter. That's an important thing. So for instance, if we had println that took in an int a, that's the same thing as println that took in an int b. Just because the variable name is different doesn't mean it's a different method. Java doesn't care what the variable names are. That's for human code writing. You know, whatever variable name we use in the parameter list is how we have to refer to it inside the logic. All right, so Java does not differentiate between two methods that have the same type of parameters that have different names. Java treats those as the same method. All right, so funny trivia word, polymorphism. So go back in here, we're asking what does this imply? So let's get the toString out now that I did that in there. So the fact that we are able to get the name of that. Let me show you something here. We'll go back into Wizard. I'll go ahead and write my own toString. Public void or public string. toString. System.out.println. Oh, no, we're just returning a string, sorry. Return. My name is this.name. Okay, it's yelling at me. I do not have access to this.name in here. Doesn't exist. And you told me why before. It says because it's private. But if I don't write my own toString method, and I instead inherit the method from my parent, what we want to understand is the nature of that inheritance. How do I inherit the method? Do I get the method myself? Or have what I really done, have I actually just gotten access to my parent where I have somebody else to pass the buck to? So if I'm the child, if I'm a wizard, and somebody asks me, for instance, I try to pass myself to the println method. And the println method says, okay, well, you're an object, I know how to print out objects, so he asked me to call my println method, or to call my toString method, rather. I'm going to say, okay, well, I don't have a toString method. As opposed to, oh yeah, I have a toString method, I got one from my parent. Inheriting that toString method does not mean I have it. It means I have access to it. Okay? And not even direct access to it. I'm actually going to pass the buck. So when the println method asks me for my toString method, I'm going to say, look, I don't know what you're talking about, but let me check with Pops. So it's going to throw the request up there to the fighter class. Fighter class and say, oh yeah, I got a toString method. No problem. I'll go ahead and call that for you. toString method bumps out a string. The child gets a string and says, there you go. Here you go. Here's the answer you're looking for. Right? So the child actually passed the request on to the parent. He didn't get a copy of all that stuff. He just had access to another person who might know the information they were being asked. Okay?
So let me phrase it. Let me make sure I understand. So let's say I'm the child. I'm the wizard in this case. You're the fighter in this case. You're the object. Okay? So you ask me for $1. I don't have $1, but my dad has $1. And I just say, sure, I'll get $1.
You can go get $1 from me.
Yeah.
Right.
Even though that $1 is private to you. That's what you're saying, though, right?
Well, but you didn't go and get $1.
No,
you asked your dad to give.
I just asked you for it. Do you have $1? And
right.
you say, yeah, I can get $1.
You didn't know where you got the $1 from.
But it's private to you. You know you
Yeah.
have
So in this
$1.
case, the wizard never actually accessed their own name. The fighter accessed the wizard's name and handed back a string that happened to have the name in it. That make sense? All right. Now it might be handy for wizards to have access to their name, though. So let's go ahead and let's put our toString back in here. So we'll say public string toString, and we'll return zap this dot name has you now. All right, and it's not happy with this because it says we don't have access to the name. And if we hover over this, it gives us some options. We can change the visibility of name to protected. I can actually have it go ahead and do that for me if I want. Okay, I can create a getter and a setter for name. So rather than actually having the parent expose name to me directly, the parent could give me a public getter, so I can get access to my own name. Well, that doesn't seem to make sense in this case, but it's certainly a workaround. Let's see what else it say. I can create a field called name in Wizard, so Wizard can just decide, okay, look, I don't need that name. I'll just make my own name. Or I'll make my own name with this, and I'll have 2 names, right? And then we can create a constant, whatever. That's unrelated. So what we're going to do is we're going to go into Fighter, and we're going to loosen the reins a little bit on this guy. We're going to make it protected. And now our wizard has access to that, because he can access protected variables. That is stuff, a protected variable is accessible in that class or in children of that class. Make sense? So now, if I go back to here, I have my wizard Gandalf, and I have my fighter Steve, and we'll go ahead and print out Steve. I am Steve, the great fighter. Then zap, Gandalf has you now. All right, make sense? Okay. So now, we have some inheritance stuff happening there. Now, the reality is we probably want fighters. You know, there's not in Fight Club. I mean, I'm an expert. He's somewhat of an expert in Fight Club, but the rest of you haven't been introduced. You don't know about Fight Club, right?
I know about the movie.
We don't talk about Fight Club.
Yeah.
Rule number 1. All right, so you know the idea here is that in the world of fighting, there isn't just a generic fighter. Okay, fighting is an idea, right? Okay, and then we're going to have specialties. So, for instance, I'm a ninja. You can probably tell, right? I move around really quietly. I can sneak around places. I can kind of get myself up into that corner there and say, well, you don't believe me?
No, I do.
Well, then you're an idiot. If you believe I'm a ninja, wasn't there a movie? Chris Farley before he died, right?
No.
Great White Ninja or something like that. Yeah, I think it was something like that. So, I always thought that would be cool. That a cool skill set for a big guy to have would be, you've seen the people who do like the breakdancing,
I have seen
but like can do like the pommel horse thing and just kind of fly. What if you saw like a 300-pound dude doing that pommel horse thing like in the middle of a mall? Wouldn't that be like amazing?
It's cool.
Well, but I mean, it's interesting enough when you see like somebody who's in good shape do it, right? But if you see a guy that is literally cheating gravity, like that should not be happening. That's like extra impressive, isn't it?
I have watched
Are
two
you talking
movies.
pommel horse like in gymnastics?
Well, yeah, but when you watch
or are you
the
talking like a hobby horse pommel
no,
horse?
no, when you watch the breakdancer guys, when they do their breakdance, like the thing that I find most impressive is when they basically do what's like the gymnastics pommel horse thing on the floor without an actual pommel horse, and they're flying around with their legs. I mean, so they have to hold up their weight and they're swinging stuff around. I mean, I would be stuck at just getting down to the ground. It's just like, wait a minute, so I got to start there, right? You want me to start down? No, I'm not doing that. Okay, if you need me, I'll be at Starbucks. All right. So, in any case, the idea might be that we don't have a such thing as a generic fighter. Okay? But in the object-oriented world, we might want to evolve our objects off of some generic template, right? Okay? All of us in here are humans, okay? But none of us are just a generic human, right? We all have we have males and females in here. We have different color hair and different heights and different ethnicities. We have all sorts of stuff that make each of us unique, right? None of us in here, okay, even you, is not just a generic human. There's more to you than that, right? Okay? If you went around the entire world, would you ever find a generic human? It doesn't exist. We're all human. We all come from the same starting point, right? Okay, we all have some stuff in common, but then we have the things that make us unique. So while the idea of a generic human certainly exists, we don't see them walking around because we're all built on top of that template. That makes sense, right? So it would make sense then for us to have, again, remember, object-oriented programming, the job of a programming language is to give us a tool that allows us to solve problems in a similar way to how we already solve problems in real life. So if we were playing God and we were building humans, all right, if we were doing that, we might say, okay, well, here is the starting instructions for a human. Okay, now, I'm not going to make one of those. That would be too generic and just weird. Okay, but I'm going to use that starting template to make other human-like things. Fighters, wizards, males, females. Make sense? Okay, but we still have access to that template. We just never actually intend to build something directly from the generic template. That template specifically exists as a starting point for other objects. Make sense? All right, so we have a keyword in Java called abstract. Okay, so abstract can be used in front of, it can be used in front of classes, it can be used in front of methods. So that's it, classes and methods. It would not make sense for it to be in front of a field. So classes or methods. Okay, but right now I'm specifically talking about it in the context of methods. I'm sorry. Let me back up for a second so I don't confuse you, because I confuse myself. It can be used in front of either of those. Today we're going to talk about it specifically in the context of classes. Okay, we're going to talk about abstract classes. So, an abstract class is a class that cannot be instantiated. It exists only to support inherit. Spelling's going downhill here. It exists only to support inheritance. Make sense? All right, so an abstract class would be like that human class. The human class would be an abstract class. Okay? We're not going to actually make humans, okay? A generic human. Okay? We're going to make specialty humans. We're going to make males and females, so on and so forth, right? Okay? Not one of these generic things. Okay? But we still need this. This guy still exists. This guy still exists for us to get the ball rolling. All right? So that's what an abstract class is. So we might decide, you know what, let's go in here and why don't we make the fighter class abstract. So we're going to say that all fighters have a name. True enough statement, right? Okay. Even the nameless fighters, like they just say he's nameless. That would be his name, the nameless. All right, so all fighters are going to have a name. This is how we'll build a fighter using his name. And here's the generic two-string method of a fighter. All right, and here, let's just say a generic fighter. Sometimes I'll actually put two strings in there like that almost become reminders. If you try to print something out and it gives you a weird response, like, oh, I meant this guy to be a wizard, and I forgot to write the two string for my wizard because this guy says he's a generic fighter. So it's kind of reminded me that I need to do something more. Does that make sense? So now, from our perspective here, fighter has not changed. But notice out here, it's now no longer happy with this line. Why is that? Because right here we say an abstract class cannot be instantiated. We can't create one of those directly. Okay? We can't make fighters. We can use fighters to make other things, but we cannot make a direct fighter. Okay? So this guy is now off limits. That's illegal. But I can still make a wizard. As we see here, a wizard is a fighter. So he's still one of those guys. In fact, I'm even using that guy's constructor to build the fighter portion of me. Right? And what makes a wizard a fighter is the fact that I have a name. That's what specifically makes a wizard a fighter. All right? Now, wizard did write his own two-string. But I'm going to take that out for right now, just to show a point. So a wizard no longer has their own two-string. We can no longer print out f because that variable is never defined. So here's our wizard. We're trying to print out the wizard. And we're going to see it's going to print out Gandalf, a generic fighter. Now, what I mentioned before is that might remind me, like, oh, okay, wait a minute. I just printed out a wizard, but I must have forgot to implement the two-string method for wizard because I'm getting generic fighter speech, right? So that's the generic fighter talking to me. Now, what I could do, though, I can do that. So now what I'm saying is all fighters have the ability to have a two-string method. But I do not presume to know what the generic form of that two-string method might be. So by putting abstract in front of that, what I'm effectively saying is any object that inherits from me is now forced to implement that method. Because they are not getting mine, because I didn't write it. I put a requirement on them that they have to write it, but I did not write it myself. All right, so here's wizard. So the type wizard must implement the inherited abstract method fighter two-string. So one of the options is here to add unimplemented methods. So now I have my public two-string. And we'll go ahead and return. I am this.name great wizard. I am Gandalf, the great wizard. Okay, so now when we created this generic fighter class, we were able to dictate that all of our children, all children of the fighter class, must write a two-string method. They have to implement it. They can't rely on their parent. They can't rely on their parent's parent. This guy is now saying, you all need to take care of yourself. Or at least all direct descendants from me. I could have children of wizard now that don't have to write two-string. They can use their parents' two-string. Wizard already implemented it. Just direct descendants of fighter must implement this abstract method. That makes sense? So abstract is really kind of a security protocol. Right? So on one hand, when we attach it to classes, it's a tool to help us build, well, at the same time, it's also a security protocol there. We're putting it into the fighter class. We're making the fighter class abstract to give ourselves the correct breakdown of object. Like you said, you were trying to make everything into an object, right? So now we're saying, okay, well, in Fight Club, we have, well, everybody's a fighter. Everybody who walks through the door is a fighter. But we have all sorts of different kinds of fighters. We have wizards. We're going to have a barbarian. So we have these different types of fighters. All right. Now, but by making this abstract, we're saying all fighters have something in common. I never expect to see a generic fighter, but all fighters have something in common, and therefore it makes sense for us to have that generic building block. But I don't want anybody to accidentally think that they can create a generic fighter and go to town with it. All right? So by making it abstract, you're kind of securing it. You're saying, look, this is a building block. Anybody who tries to create one of these directly is going to get screamed at. Java will take care of that. That's what abstract does. It's a security measure in that regard. We don't need to make this guy abstract in order to use them as inheritance. If we make him abstract, we can only use him for inheritance. That makes some sense? So abstract is a security measure that kind of dictates how we should be using it. Similarly, when we make a method abstract, we're saying, hey, anybody who's going to inherit from me has to write this guy. It's a requirement. He's got to have one of those. All right? So, having said that, we're going to go ahead and we're going to create a public abstract. Let's call this guy, well, we'll have him return an int. And it's going to be called attack. So all fighters must have an attack method. So I'm going to steal this guy here for a second. And we'll go into wizard. And we'll go ahead and implement this method. All right, and we're going to want to go ahead and get access to the random class in here so we can randomly roll some stuff. So we'll say private random r, and we'll import java.util. Then after we have our parent build us, because we have to do this beforehand, we'll say r dot, oh, you know what? This is a perfect use for fighter. All fighters are going to have to be able to roll random numbers, right? For doing their attacks and stuff. So why don't we go ahead and put the random class in here. And then and we'll make this guy protected so the children have access to it. And then we'll say this dot r is equal to new random inside the constructor for our fighter. So now a wizard, we no longer need random up here. A wizard, when he gets created, he'll automatically get a random function. So we'll have this guy return r dot nextInt. So he's going to use that protected field r to grab a random integer for the attack method for this wizard. That makes sense? But now let's say that wizards actually have, maybe they do a bigger attack than somebody else. We're going to create a scenario here in a few minutes. Okay, so a wizard does this type of thing. So now what we're going to do is we're going to come back in to our, well, we're going to create our barbarian class, right? So we have our class Barbarian, and we're going to say Barbarians also extends Fighter. All right, so now if we were to draw our picture here, we have a wizard and we have a barbarian.
Just out of curiosity, do you have to add, I mean, now that we have that fighter up there, do we have to tell it extends fighter?
Yes.
Okay.
Yeah, otherwise it doesn't know.
Okay.
Yeah, it would just be making guesses. Yeah, the only automated thing is when we have
Object.
something that extends object.
Gotcha.
Yep. Yeah, and that's not required. We can leave that out.
So you're essentially tying the fate of these separate classes.
Yeah.
To,
With the extends keyword. Yeah, that extends keyword is absolutely required for every time us, when we're writing the code, are going to inherit from something. There's never an option for us to not use extends. Okay? The only special case is when we create a class that we don't intend to inherit off anything we wrote, but we kind of accept the fact that it will automatically inherit from a generic object. But now we can inherit from Java's built-in stuff too. We can inherit from string. Some classes are what are called final classes. And if you make a class final, you're saying you cannot inherit from me. So making a class a final class, I think actually a string might be a final class. I don't think we can extend string. Java screams at us and says, wait a minute. We don't want you taking that. You can't make your own strings out of it. If you want to make strings, make your own string. So that would be a final class if something has a security measure in it or something like that, or if it has a bunch of private stuff for good reason. You know, maybe a particular class that's dealing with, you know, a security protocol and has a whole bunch of private variables, and by extending it, you really don't have access to the stuff you need to have access to. So it makes no sense to extend it. On the other hand, if you make those variables protected and you really don't want just anybody messing with them, by inheriting it, you now have access to those protected variables. So that could be a security problem. All right, so a wizard's going to know how to attack, and we'll just have a wizard roll a random number for right now. And we'll have a barbarian also learn to attack. And we'll go ahead and put the constructor in here. So we'll let this guy write most of it. So he goes ahead and he puts in the thing that calls upon the parent. And then we're missing another, so we'll add the unimplemented method. So we went ahead and put those guys in there for us. This override keyword is a Java directive to the virtual machine that actually makes things run a little quicker. If it knows something is being overrided, it'll look there first when it's looking for global functions, but it's never required. It's more of a performance thing. I rarely write it. The only time it ever shows up in my code is if I auto insert stuff like that. I don't write it myself.
Today I saw it into my code like reserve or something. Reserved.
Reserved. With what?
It comes like same way.
Oh, yeah, another thing like this?
Reserved.
Yeah, I don't know.
I think something reserved.
Yeah, it might exist. It might exist. But those are directives. There's also a thing where you can, this syntax we're looking at right here, this is called Javadoc. It's a known XML-based syntax. You can make your code self-documenting. So you can put the Javadoc directives into your Java program, and then you can run the Javadoc command on it, and it will generate HTML pages in this format for all of your code. You can write the comments and stuff, and it will literally give you a constructor summary, a method summary, along with what each method does. It'll do all that for you to give it to you in this format. Not that helpful a lot of the time, but for example, if you wrote a really large application that you're turning over to somebody, rather than you having to create all this documentation, Javadoc allows you to generate the documentation. As long as you committed to following the Javadoc standard and putting the little blurbs before every one of your functions and stuff like that. As long as you did that, then you've gained the ability, the advantage of having the rest of the stuff show up on there. Make sense? All right. So here's our barbarian. Now, we're going to go back up to fighter. And we're going to say that all fighters have a number of hit points. So HP, that's hit points. Okay, so that's how much. So for those of you who aren't into Dungeons and Dragons LARPing type stuff, so hit points is the your life energy. If I'm in a fight, I go unconscious when my hit points go down to 0. So if I start with 10 hit points and you start beating up on me, when I get down to 0, I'm out. All right, so that's what hit points are. All right, so pick your favorite video game. It's that number that goes down when it makes you die. That's what hit points is.
What's our number string? I mean, what's our...
Yep, so this is for a generic fighter. Every fighter has a number of hit points. But different types of fighters might have different numbers of hit points. For instance, barbarians innately are probably tougher physically than a wizard, right? Conan versus Gandalf in a fist fight's not going to go well for Gandalf, right? Okay, but you give Gandalf a little distance and let him cast a couple spells, Conan's probably not going to make it out of there all that well, right? So that's kind of the punchline. How many of you in here don't know either of those character names, Conan or Gandalf? So you know Arnold Schwarzenegger?
Yeah, I know that.
Yeah.
That's Conan.
Yeah, Conan. Arnold Schwarzenegger is the Austrian actor. Here, I'll show you the picture of him. Yeah, I'm sure you've seen him before.
Bodybuilder.
Yeah, he used to be a bodybuilder. Then he was
Conan
yeah.
the Barbarian, and I'll show a picture of him.
The movie Apache.
Yeah, this is Arnold Schwarzenegger. All right, so he was an actor. Well, he was a bodybuilder. Then he was an actor. So Conan was kind of his first real role. I don't think he really even spoke English at the time. Yeah, but then he became a big movie star, and then he became the governor of California. Yeah, he was the Terminator. Yeah, he was the Terminator in there. Yeah. Yeah. Now I don't know what he's doing now. And now he's selling some iPhone game, the tank battle game or something like that. I don't know. Oh, probably. Yeah. Interesting fact about Arnold Schwarzenegger. Do you know he's extremely short? I think he's like 5'1" or something like that.
Really?
Yeah, if he's not 5'1", he's a lot shorter than you expect him to be. He might not be 5'1", but he might be something like 5'5", or where he plays these big hero parts. You would assume he's 6'2" or something like that. Must be.
He's with short actors like
Tom Cruise is short.
Cruise is short. So is Sylvester Stallone.
Mm-hmm. Yeah, but that's kind of an interesting thing. Chuck Norris is tall, I think. Yeah, we should actually have a Chuck Norris class in here. So we have Barbarian, Wizard, Chuck Norris. It's instantly win. The fight is over before it begins. All right, so in any case, I don't even know how we get onto that with the... Oh, yeah, Conan is Arnold Schwarzenegger. Gandalf is from the Lord of the Rings movies. He's the white-haired wizard guy on the good guys. He's with the good guys from the Lord of the Rings. Yeah. Yeah, the you shall not pass, that guy. That's Gandalf. Yeah, right? What's this? All right, so wizards are going to be wimpier than barbarians. That's from a physical, okay? Because that's how hit points will work, right? Okay, so we would not expect Gandalf to win a fist fight against Conan. One punch and Gandalf is in trouble. Right? But Gandalf's a wizard. He's not going to plan on getting anywhere near Conan. He's gonna.
So the inverse of that is intelligence usually.
Yeah, Conan's an idiot, and the wizard's probably really bright. It's kind of the idea. All right, but we're going to start with just hit points here. All right, so we're going to go in here. So now, when we're building a wizard is going to go ahead and set their hit points. All right, so we're going to have the wizard set their hit points to a relatively small number. So let's say their hit points is going to be some number of hit points between, let's say 3 and 12 or something like that.
I'd go with like 10, and then barbarians would like 20 or 30.
Yeah, but you can do a range still. That's fine. So let's do, we're going to say this dot HP is equal to R dot next int, and we're going to give it the bound number. So the maximum number of what's the maximum number of hit points we want to have? You want to have 12 as the maximum? Okay, and what is the minimum number of hit points? Do 5? Okay, so we're going to say 7 plus 5. So this will be, actually we want to do 8. Yeah, this will do 0 to 7 plus 5, so that would be 5 to 12. Yep. So r dot next int, passing in a number, will give us a number between 0 and 7. And then when we add 5 to that number, that'll give us 5 to 12. Okay, so that's going to be our wizard's hit points. As opposed to, if we go over to our barbarian, what's the max and min for a barbarian?
Double at, say, 16 plus 5.
Okay, so they're tougher. All right, now we can keep going down the line, have intelligence playing into this and stuff like that, but we want to keep this as a relatively simple example. All right, so the thing that's going to play in here, though, is that barbarians have strength, right? Their strength is an important aspect to how they attack. All right, so we're going to say specifically to barbarian classes, barbarian-based classes.
So we have a hit modifier.
Yep, we're going to have a protected int strength. All right, so that means any class under barbarian, a barbarian and any other barbarians, things that inherit from barbarian, would get strength. Okay, wizards don't need strength; they're frail. They just need to be able to hold the wand or the stick or whatever their, whatever the source of their power is. All right, so we're going to go ahead and set the strength. So there's going to be this dot strength is equal to r dot next int. And we're going to do this as a modifier just for our little game here. So why don't we just say it's 4. I'll just say 4. They get a 0 to 3 modifier. So they get to add on to their damage that they're going to do when they attack somebody some additional amount of damage between 0 and 4 depending on their strength. Make sense? All right, so this is just a little stupid game when we're running low on time. So we'll have that working. So that guy gets some strength. A wizard is going to have a protected int mana. So a wizard's source of power comes from their magical energy. And every single time they cast a spell, it takes some magical energy. Okay? So if Gandalf is fighting Conan, and he's casting spells down on Conan, and all of a sudden he's drained of magical energy, and Conan's still alive, that's bad news bears for Gandalf. All right? Because Conan's now going to run up to him and probably rip his head off. That's what's going to, and then, I don't know, what is it? Conan was it with Crom, right? As he prays to some god Crom or something like that. Okay, so this is protected int mana. And we're going to say this dot mana is equal to r dot next int. And we're going to say that each spell, just for our little sample here, takes 5 mana. Okay, for him to cast a spell. So we're going to give him a random number between... we probably want to have a minimum of 2 spells.
10.
So we'll have, so let's give it 10 plus 10. So it'll be 0 to, actually let's do 11. So 0 to 10 plus 10. So the minimum amount of mana they'll have is 10. The maximum will be 20. All right, so that's their amount of mana. All right, so now when a wizard attacks, he's going to do some amount of damage. So we're going to say he's always casting a spell when he attacks. So we're going to say if this dot mana is greater than or equal to 5, as long as we have enough magic to cast a spell, we'll go ahead and say this dot mana minus equals 5. So we'll reduce our mana pool, and then we're going to return. And a lot of times, and we're going to do this not based on random. Oh, actually we will. So we're going to return r dot next int, and let's say that this guy is going to do 3 to 7 damage. Good enough. This might not be fair, but whatever. Otherwise, we're going to return 0. It's a feeble attack. Okay, he's out of power. Okay. In fact, we'll even have him say that. System.out.println. Out of mana. Or the cool kids just say OOM. The video game guys. Okay, out of mana. All right, and return a 0. So this is how wizards attack. Now, barbarians, these guys are going to use their fists. All right, and he doesn't run out of energy, but he's not going to hit quite as hard. All right, so our wizard, he did that level of damage. A barbarian is going to do an amount of damage between 0 and 2 plus this dot strength. Plus a strength modifier for additional damage. All right? So that's how a barbarian will attack. Now, so let's do it this way. We're going to write this at the fighter level. Public Boolean take damage int amount and we'll say this dot HP minus equals amount, and then return this dot HP less, let's see, take damage is going to return whether or not he's still alive. So he'll return true if his hit points are still greater than 0 and false otherwise. So after somebody takes damage, they might die. Okay? All right, and we'll just go back and forth with this. All right, now what we want to do next, I'm going to write a reminder because this is going to be something we're going to be building on for next class. Your assignment's not directly related to this. So having said that, yeah, let's talk about your assignment so I can give you kind of some hints on how to get started. And I'll put this up after we're done here. All right, so your assignment is also going to be dealing with writing some various classes and making these guys work together, and it's going to be another game. So there exists a card game called Blackjack. Have you heard of Blackjack before? All right, so the card game Blackjack, you can I'll give you a link to a place where you can go and play it online and understand the rules. But the idea is that every player is dealt a couple of cards. All right, and you just do it something in the spirit of Blackjack. There's some versions of Blackjack where a card is dealt face up, and that don't worry about that. Write a Blackjack-like game. All right, so a player is dealt a couple of cards. All right, so I'm holding the cards in my hand. These are playing cards, like 2 of clubs, 3 of spades, that kind of stuff. All right, now I add the values of my cards together. So for instance, so this is Blackjack. If I had the 3 of clubs and the 6 of diamonds, this hand has a value of 9. The goal is to get as close to 21 as possible without going over. All right? So, with a value of 9, the dealer the person who hands out cards, would ask me, do you want to hit? Do you want another card? Okay, and if I have 9, I'm probably going to say, yeah, give me another card. Okay, I'm not going to win with a 9, first of all, and I feel pretty confident that I can, well, actually I feel extremely confident that I'm not going over 21 on the next card. Okay, okay, so he's going to give me another card. So let's say he gives me the 10 of spades. Okay, so now I'm at a hand value of 19. Okay, now I can still get to 21 if I take another card and he gives me a 2. Okay, there's only 4 cards in the deck that are going to do that for me. Now, an ace, though, I can get to a 20 with an ace, because an ace can have one of 2 values. So that's really the one little logic trick in the game. So the ace is a 1 or an 11, depending on which one benefits you. So for instance, if I got an ace here as my next card, this would then become a hand value of 20, as opposed to a hand value of 30, right? Because 30, the game is over. I've lost. At least I'm not winning. Other people might still be playing the game, but I'm not winning.
So ace is 11?
Or a 1. Or a 1.
So what about
1 or 10?
king, 10?
All those are 10.
Face cards are 10.
Yeah. Everything. So everything is its number.
Okay.
All the face cards, Jack, King, Queen, are all 10. And an ace is either a 1 or an 11.
And 10 is 10?
10 is 10. Yep. The number is the number. And I'll put a link up. It's a very well documented game. All right. So the idea here is that we're not gonna create a competition where you're playing against somebody else for the homework assignment. The homework assignment is just going to have you and a dealer. Okay. So the dealer is going to have to fill up a deck of cards. They're going to have to shuffle that deck of cards. Okay. So you're going to have an array of card objects. We've had arrays of integers, arrays of chars. What keeps you from having an array of cards? Okay, so what would an array of a card object look like? Card array, the deck, is equal to new card array 52, something like that. You use it the exact same way as you would otherwise, except when you say the deck at bucket 4, that's a card object. Not a char, not a string, not an int, it's a card. And anything you teach your cards to do, they should be able to do. So the homework assignment.
There's one more if you get same cards. You can divide it.
Yeah, if you want to do something crazy, you can. Just do something in the spirit of Blackjack. Okay, I want you to mess with the logic of the cards. You don't have to do anything crazy. All right.
After assignment, we can go to Vegas. No?
That's right. That's right. So homework assignment is create a Blackjack simulator. A dealer should create a deck of cards, shuffle the deck, and then deal 2 cards to the single player. So we only have to have 1 player in this one. All right?
Means he gives you 2 cards?
They'll give you 2 cards, and you'll see the cards on your screen.
Okay.
Text-based, right? It'll say you have the 2 of clubs and the 8 of spades for a value of 10. Hand value is 10. Then the dealer's going to ask you, do you want another card? Okay? The dealer will keep asking if the player wants another card until they say stop. All right? The player then has their hand value revealed. They're not actually going to play blackjack against anybody. We'll kind of add some of that in there next time. So this is kind of like what we did today with the Connect 4, where we're adding things to our board, making the board do things, but not really checking for a winner. Okay? But what we should do is the game should stop when the player busts. That is, goes over 21. So we're not going to keep asking the player, do you want another card if they're sitting at a hand value of 24. Make sense? We're going to say, oh, you're done. All right. So I'm not going to ask you for another card if you busted, but up until that point, if the player's sitting at a 20 and they want to roll the dice on an ace, they can. All right. You should never do that, by the way. If you are in Vegas and you're playing blackjack and you have a 20, unless all else is lost, and somebody's showing a blackjack, you stay.
Just doing splits too.
No, he already asked that.
Oh, yeah.
Yeah.
I think above 16 you...
I've pretty much explained here what you need to do.
You never ask me.
Don't worry about splits. Don't worry about anything fancy. Most of you either haven't played blackjack or have a very rudimentary understanding of blackjack. Simple blackjack. Okay? What's the real challenge with this assignment? The challenge of the assignment is going to be determining the value of the hand, especially in hands that have aces in them. Is the value, you might have a hand that's worth 20 with an ace, or a hand that's worth 30 with an ace. Well, I'm going to keep the 20 because that hasn't busted yet. The 30 has busted, so I should be able to give them the option to try to get another ace if they wanted to. That make sense? So the complexity is building card objects, and what does that mean? Building a deck object, what does that mean? Shuffling a deck. Having a dealer object, what does the dealer do? The dealer shuffles the deck, deals cards to the player. What does the player do? The player is having this interaction. So this assignment is less about the complexity and more about lots of objects working together. Make sense? Questions, comments, concerns, bribes? All right, I will see everybody next Wednesday.
So there will be almost 3 classes then?